Minimum Control Speed, VMC, is a critical safety concept for multi-engine aircraft. In this video, we will first understand the basic concept of VMC. We will then discuss the factors that affect VMC. Finally, we will cover minimum control speed for different stages of flight, including VMCG, VMCA, and VMCL. VMC is the minimum speed at which the aircraft remains directionally controllable after sudden failure of the critical engine, using maximum available rudder, without exceeding specified bank angle limits. In simple terms, below VMC, the rudder is not powerful enough to counter asymmetric thrust. VMC is calculated in the most adverse configuration, to ensure an adequate safety margin. We will discuss this concept in more detail later in the video, with specific reference to VMCG, VMCA, and VMCL. Now, as you can see on screen, various factors affect VMC. To understand this, remember that VMC is the minimum speed at which directional control can be maintained after an engine failure. Directional control is required to counteract the yawing moment created by the live engine. This control is achieved primarily using rudder, and in some cases, with a limited bank angle towards the live engine. Any factor that increases the yawing moment produced by the live engine will increase the VMC requirement. For example, higher engine thrust increases asymmetric yaw, and therefore increases VMC. Similarly, high density altitude indirectly increases live engine thrust, which again leads to a higher VMC. On the other hand, any factor that improves rudder effectiveness will reduce the VMC requirement. A forward center of gravity increases the moment arm of the rudder, making it more effective, and therefore reducing VMC. Extension of flaps and landing gear also improves directional stability and rudder effectiveness, which further reduces VMC. VMC is calculated in the most adverse configuration, to ensure an adequate safety margin. We will discuss this concept in more detail later in the video, with specific reference to VMCG, VMCA, and VMCL. Now, let us get into the details of VMC with respect to different phases of flight. We will discuss VMC on the ground, in the air, and during landing. That is, VMCG, VMCA, and VMCL. Let us start with VMCG. VMCG is the minimum control speed on the ground. It is the calibrated airspeed during the takeoff run, at which, following the sudden failure of the critical engine, the aircraft can be kept under control using only the primary aerodynamic controls. Nose wheel steering is not used, and control must be sufficient to safely continue the takeoff using normal piloting skill. During the determination of VMCG, the aircraft is assumed to be accelerating along the runway centerline with all engines operating. After the critical engine failure, the aircraft must not deviate more than 30 feet laterally from the runway centerline until directional control is regained. The yawing moment created after engine failure is directly related to the thrust produced by the live engine. On the ground, the only aerodynamic surface available to counter this yaw is the rudder. The minimum airflow speed over the rudder required to maintain directional control is known as VMCG. The primary factor affecting VMCG is engine thrust. As engine thrust increases, the yawing moment increases, and the rudder requires higher airflow to remain effective. Therefore, VMCG increases with an increase in air density. To manage control speeds, engine thrust may be permanently derated by the operator. This helps achieve lower values of VMCG, VMCA, and VMCL. VMCG must be established under specific certification conditions. These include the most critical takeoff configuration, maximum available takeoff thrust, the most unfavorable center of gravity, the aircraft trimmed for takeoff, and the most unfavorable takeoff weight. VMCA is the calibrated airspeed, at which, when the critical engine is suddenly made inoperative, it is possible to maintain control of the airplane with that engine still inoperative, and maintain straight flight with an angle of bank of not more than 5 degrees. VMCA may not exceed 1.2 vs, with maximum available takeoff power or thrust on the operating engines, the most unfavorable center of gravity, the airplane trimmed for takeoff, and the maximum sea level takeoff weight. The airplane is in the most critical takeoff configuration existing along the flight path after becoming airborne, except with the landing gear retracted, and with the airplane airborne and ground effect negligible. During recovery, the airplane may not assume any dangerous attitude, or require exceptional piloting skill, alertness, or strength, to prevent a heading change of more than 20 degrees. VMCL, the minimum control speed during approach and landing with all engines operating, is the calibrated airspeed at which, when the critical engine is suddenly made inoperative, it is possible to maintain control of the airplane with that engine still inoperative, and maintain straight flight with an angle of bank of not more than 5 degrees. VMCL must be established with the airplane in the most critical configuration, or, at the option of the applicant, each configuration, for approach and landing with all engines operating. It must be established with the most unfavorable center of gravity, the airplane trimmed for approach with all engines operating, and the most unfavorable weight, or, at the option of the applicant, as a function of weight. Go-around thrust setting must be used on the operating engines. In demonstrations of VMCL, lateral control must be sufficient to roll the airplane from an initial condition of steady straight flight, through an angle of 20 degrees, in the direction necessary to initiate a turn away from the inoperative engine, in not more than 5 seconds. Let us now summarize the 3 minimum control speeds across different phases of flight. First, VMCG. VMCG is the minimum control speed on the ground. It applies during the takeoff run after failure of the critical engine. Directional control must be maintained using primary aerodynamic controls only, without nose wheel steering, and lateral deviation must not exceed 30 feet from the runway centerline. Next, VMCA. VMCA is the minimum control speed in the air. It represents the lowest speed at which the aircraft can maintain directional control after engine failure, with a bank angle not exceeding 5 degrees. VMCA must not exceed 1.2 times stall speed, and is determined with maximum thrust, unfavorable center of gravity, and negligible ground effect. Finally, VMCL. VMCL applies during approach and landing, with all engines initially operating, followed by sudden failure of the critical engine. Control must be maintained with a bank angle of not more than 5 degrees, using go-around thrust on the operating engines. In VMCL demonstrations, the aircraft must also be capable of rolling 20 degrees away from the failed engine within 5 seconds. In summary, VMCG applies on the ground, VMCA applies in flight, and VMCL applies during approach and landing. All 3 speeds ensure the aircraft remains controllable following failure of the critical engine. That brings us to the end of this explanation on minimum control speeds. We hope you found this video clear, useful, and easy to understand. If it helped your study or revision, please like the video and share it with fellow pilots and trainees. Do not forget to subscribe for more Airbus A320 technical explanations and exam-focused content. Thank you for watching, and fly safe.